I'd like to introduce you now, and it's my pleasure to meet the 2015 MRS Medal winner, Dr. Richard Kaner. Dr. Kaner, thank you for being with us today.
Oh, thank you.
Congratulations again on your MRS medal. Now, before we talk about your award talk, let's talk a little bit about what led you here. How did you come to be interested in conducting polymer nanofibers?
I spent 4 years as an undergraduate in research at Brown University, and I was working on semiconductor crystals. And a friend of mine said we just made this really amazing discovery and I should get my degree and get over to the University of Pennsylvania, where I worked with Alan McDermott and Alan Heeger. They're the founders of the field of conducting polymers, and 20 years later, they shared the Nobel Prize for my work and 100 other people's work on polyacetylene.
Now, your talk is titled Synthesis and Applications of Conducting Polymer Nanofibers. So let's talk first about the synthesis aspect. What are some of the challenges that had to be overcome?
Well, the first thing is, the problem with polyacetylene is it's not air stable. So nobody uses that these days. What we use is polyaniline and polypyrrole and polythiophene, which are air stable. But the problem is the world around you is plastics. And you can ask why, and of course the answer is they're inexpensive, but furthermore they're processable. So if you want to make a telephone, let's say, you melt the polymer and you injection mold it. If you want to coat a carpeting, you dissolve a polymer and you coat it. Well, conducting polymers are conjugated, so they don't melt, they don't dissolve. So the first challenge is, how do you process this material that doesn't do this? And so what we came up with is the idea of making nanostructures. And when we did this, in the dough form, they disperse in water. So now you have conducting polymer paints and inks. And then we discovered that if you coat these on a surface and hit them with a laser or a flash of light, they actually melt. So all of a sudden these very difficult to process materials become processable.
Now, what challenges still remain then?
Well, there's still challenges in scaling these materials and tailoring them for specific applications.
And then the practical applications of your work, which you were just touching on. What are some of the devices or processes that the general public might be seeing soon as a result of all your work and research?
So some of the things we've touched on are sensors. So these materials are very sensitive, especially polyaniline, to acids and bases. Most materials are sensitive to organic vapors, but so you can add these into known sensors. But I think the thing I'm most excited about is we started working with a company called Water Planet Engineering, and they make membranes. And they make membranes to clean up the mess left by oil fracking. So there's a tremendous amount. For every barrel of oil you pull out of the ground, you pull out 7 to 10 barrels of oily water. And what they have is a high-speed, efficient centrifuge, which gets 99% plus of the oil out. But it's the last 1% that you need a membrane to polish off.
And that's where your work comes in.
That's exactly right.
Fantastic. Again, 2015 MRS medal winner, Dr. Richard Kaner. Thanks for your time.
Thank you.